02/02/2020. That's February 2nd, 2020. Well, I'm sitting here looking at the Raspberry Pi stuff, and noticed I haven't really talked about how I keep CPU temperatures cool and how I monitor CPU temperatures. So I thought I'd just go over that quick. A couple of things. I just upgraded to the Pi 4, for those that don't know. I got the Canna Kit Pi 4, which came with this nice little fan. It also came with a case where that fan would normally attach right over the CPU, but obviously I have the Pi Easy Connect board in here still for now. That's going to be removed, and we're going to switch all of our greenhouse controller stuff over to an Arduino and let the Arduino feed the data to the database on the Pi, and let the Pi manage the database, web pages, controls, etc. Anyway, so I have that fan up here. That's running full-time off of the main board here, off of plus 5 volt pins, well, 5 volt and ground. And then previous to having this fan in the Pi box, I installed this fan for cooling the CPU directly. That blows a tremendous amount of air down through. And then to keep the box cool when the box is closed, there's this fan. I used to have a separate DS18B20 sensor in the box. I probably will put one back in here once I finish with my upgrades, and then this fan will be operated independently of CPU temperatures. However, for now, I shortened my script down, and CPU temperature kicks on both this fan and this fan to provide extra cooling to the processor and the box when it exceeds 140 degrees on the CPU. And so in order to get CPU temperatures in my script, where I grabbed all the data from the different sensors and pumped that into the database with PyCurl, in that script is some code that grabs RAM usage, CPU usage, CPU temperature, all sorts of stuff. So I'll just show you that code quickly, and maybe I'll share that out on hamradio.cc. For those who don't know, I am sharing some of my command line and Python code stuff now on hamradio.cc. I'll provide a link below for that particular, for this particular video. So basically we're just running a regular Python script, and then we're setting our pins for sensors and for turning stuff on and off. Also, I guess I should mention, those fans are operated from the GPIO output through an 8 relay board, which is up here, and those fans are tripped through the relays. So there are 12 volt fans run off of the GPIO, which triggers these 5 volt relays and turns 12 volt power on from the solar battery bank to the fans. Part of the reason I don't run these fans full time is because my design for this system is to be as efficient as possible in power usage. And so if we don't need to run a fan or a pump or whatever, we eliminate it. And if we have to write code to do that, we do it. So anyway, back to the script. I guess I'll turn my headlight off here so as not to blind you. Let's see. That's for DS18B20 sensors. Here we go. We're getting the CPU temperature here, and like I said, I'll share this code on the forum on hamradio.cc. I suppose we'll make this Raspberry Pi, how to set up your Raspberry Pi video, part 14. So all we're doing here is using a command line to take a look at the actual CPU temperature on board, the actual temperature sensor that's on board the CPU of the Pi 4, and then of course we're calculating that, we're converting that into Fahrenheit from Celsius, and then we're taking a look at that and comparing it you know, against a high or low set point. And if we're above 140 degrees Fahrenheit in this case, those fans come on, and you can see that trips 2 different relays that trip those 2 different fans on. And the reason for that, again, is because I did have a separate sensor for box temperature, and I will again when the upgrades are complete here. And of course, if the temperature falls back below 135, we trip it back off, and that's really all there is to it. But I just thought I would share how I go about cooling my Raspberry Pi, And I'll pull up the SQL dashboards here and we'll look at the chart here. Actually what I'll do, okay, after a bit of fumbling. So we're looking at CPU temperature over the last 48 hours, and you can see it fluctuates a good bit, reaching, looks like 152.1-ish as a peak. And since I put the CPU script in, you'll see it hasn't really gone over 140. So that means our fan system is working well at maintaining our temperature. This is not so important for this processor this time of year, but in summertime when temperatures in the greenhouse can exceed 140 degrees very rapidly when the sun comes out, it's very important. And that's also part of why we're going over to the Arduino for our main ventilation and pumping controls, so we have a little bit more reliable interface, so that we don't have a failure and end up cooking all sorts of stuff. Let's just take a look at the temperature specs. In fact, I'll throw that in as a video overlay here so you can look at the actual temp specs for the Raspberry Pi 4. You'll see 150 degrees Fahrenheit is a pretty low temperature actually for that CPU. They're rated, I think, for like 250 Fahrenheit max or something like that. Anyway, we'll take a look at that. And like I said, that script is run from the cron tab. Let's take a look at the cron tab. And then it uses another script that actually does the check. So I'll just show you this quick, and I'll try and throw this in the forum. So that's the second one there. You'll see. Let me zoom in. Excuse me. You'll see it's the root CPU check, and it runs every minute, every hour, every day, every month, every week, every. So every minute of every day that script runs. And what that script does is basically check to make sure that the CPU script that I just showed you before is actually running and active, so that if something happens and that script fails, the cron tab will actually restart that script for us. So let me just bring up that script, and I'll share the code with that as well, of course. Emacs root CPU check, I believe it's called. There you go. So you can see it's a pretty simple script. Basically just while true, do root CPU.py and wait, cache exclamation sleep 10 done exit. And basically all that does is make sure that the CPU temp script is running. If it's not, it starts it up. If it is, it doesn't. So pretty straightforward and simple. But that ensures, and that ensures that no matter what happens, if we reboot or whatever, that script always comes up and runs in the background and makes sure that the processor stays cool. So that's what I do for cooling my processor. I know it's probably overkill, but my aim for controlling and monitoring my greenhouse is to have really robust hardware and really robust architecture backed by really good code, so that things stay cool and we don't have failures. Because all it takes is one failure in, say, April or May, after a cold night, you've had to run the stove, you got the thermal mass temps up pretty good, it's 70 in here overnight, the sun comes out, by 10 o'clock in the morning you can see 120 degrees in here. You can cook seedlings really quickly. So it's very critical environmental controls. Those vents need to come open when they need to come open. And there's a very short window, if they fail, to save it. So that's that. I hope you found this interesting or informative. If you want to know more or you have questions, by all means please do so in the comments section below, or you can sign up over on hamradio.cc and you can comment in the thread there, and I'd be glad to help anyone who has questions or comments. Thanks for watching the Pharmacy Seeds Network, and hope to catch you in the next video. So I got the stove cranking up here. I got some nice hot cherry wood in it, and that's bringing temps up in the greenhouse enough that the processor hits that 140 point and brings those fans on. So I thought I would get a clip of that. course, I will probably have to wait a bit until they kick back on. So again, it'll be a shorter wait for you than it will for me. Okay, see if we can put enough load on this processor to get the temperature back up. Had to open a video editor to do it. Ah, there we go. That did it. So you can see this fan come on. That one, it's hard to see, but it's on. And you can see the two relays on the bottom there are fired. The third one up there is the pump relay. I'm transferring heat from the stove thermal mass to the big thermal mass. But I just wanted to get a clip of those coming on and off by themselves. You can see it's back off again. And since we're rendering, it'll probably trip in again shortly. And there we go. And so that loud buzzing noise in the background is a combination of a top job crappy amplifier I have here until the new one comes, and the pump being on. The pump makes a tremendous amount of noise. I'll probably go back and add some capacitors or ferrite beads or both to eliminate that noise. But I just mainly wanted to get a quick clip of the fans coming on and off. So there you go.